National 5 Chemistry Unit 1 4 Bonding Structure and Properties. Covalent bonding. This occurs between two non-metal atoms. Two electrons are shared between the two atoms and are held in place by the mutual attraction of both positive nuclei to each of the electrons, which have a negative charge. In molecular elements, there are 8 diatomic elements, 2 atoms held by covalent bonding. Hydrogen, H2, oxygen, O2, nitrogen, N2, and all of the group 7 elements, the halogens. In molecular compounds, when non-metal atoms join, e.g. water, H2O, and ammonia, NH3, methane, CH4, or the diatomic elements, these have specific shapes because of the covalent bonds. Covalent molecular substances tend to have low melting and boiling points because they have only van der Waals forces holding the molecules together. Van der Waals forces increase with increasing size. Polar covalent bonding. This occurs when two non-metal atoms form a covalent bond, but the electrons are not shared equally. They sit closer to one of the other. The one closest to the electrons then has a partial negative charge, it's called a D-, while the other atom has a partial positive charge, D+. This is found in water. Covalent network substances, carbon in the form of diamond and graphite, silicon dioxide, silicon carbide, have high melting and boiling points because all the atoms are interlinked by strong covalent bonds, which take a lot of energy to break. Ionic bonding between a metal and a non-metal atom. The metal loses its outer electrons to form a positive ion. The non-metal takes these electrons to form a negative ion. In both cases, the ion ends up with a full outer electron shell like the noble gases. The electrostatic force of attraction holds these oppositely charged ions together very tightly. This is why ionic compounds tend to have high melting and boiling points. The structure is a large lattice. Metallic bonding. Found in metal elements, the atoms lose their outer electrons, which are then free to move from one metal ion to the next. This free movement of electrons is why metals conduct electricity. Solubility. Like dissolves like. Ionic compounds dissolve in polar solvents, like water. Covalent compounds, like candle wax, dissolve in covalent solvents, like hexane. Electrical conductivity. Metals conduct when solid or liquid. Covalent compounds don't conduct at all. Ionic compounds only conduct when molten, liquid, or in solution because the ions are then free to move. So the type of bonding is metallic. Electrical conductivity, yes for liquids, yes for solids, insoluble, and high melting points. Ionic bonding, no for electrical conductivity in solids, yes for in liquids, yes for when in solution, high melting and boiling points. Covalent molecular, no for conductive electricity at all, and have low melting and boiling points. And covalent network, no for conducting as a solid, no for conducting as a liquid, no for conducting as a solution, but have high melting and boiling points. There is one exception, that being graphite, which will conduct electricity as a solid. An electrolyte is used to complete the circuit and is usually a solution of an ionic compound. This allows the charges to flow.